All right, this is going to be for parts 3 through 5. All right, so again, we're going to go back over here, to part 3. Part 3 is saying h of x is equal to f of x times g of x. Find h prime of 2. All right, so I see here that this is a product. So I have to use the product rule to find the derivative of h. So I'm going to write out the product rule. So h prime of x, or the derivative, is equal to the derivative of f of x times g of x plus f of x times the derivative of g of x. All right, now, once we have that written out, we have to find the derivative. All right, so the derivative at 2 is equal to f prime at 2 times g at 2 plus f at 2 times g prime at 2. All right, so we're going to go back to our chart. All right, so f prime at 2 is negative 3 halves. G at 2 is 1. All right, then f of x is 2, and g prime of x at 2 is 0. So now I'm going to go back and substitute that into my formula. All right, so f prime at 2 again is negative 3 halves. Then g at 2 is 1 plus f at 2, which is 2, times g prime at 2, which is 0. All right, so negative 3 halves times 1 is negative 3 halves, and 2 times 0 is just 0. And anything plus 0 is itself. So the derivative of h at 2 is negative 3 halves, and you're done with that particular one. All right, moving on to part 4. In part 4, it says that h of x equals f of x divided by g of x. Find h prime, or the derivative of h at 1. All right, so if you notice, f of x divided by g of x, that is a quotient. So to find a derivative of h of x, you're going to use the quotient rule. So h prime of x is equal to the derivative of f of x times g of x minus f of x times the derivative of g of x divided by g of x squared. All right. Now we want to find a derivative at 1. So we're going to substitute a 1 in for x, just like we did previously. The derivative at 1. Then g at 1 minus f at 1 times the derivative of g at 1 all over g at 1 squared. All right, now everybody knows what the table looks like, and you should have it with you so you can see it. So I'm just going to go by the information given to me from the table. All right, so the derivative of h at 1 is equal to the derivative of f at 1 is negative 2. All right, times G at 1. And G at 1 is 3. Minus F at 1. F at 1 is 4. Times the derivative of G at 1, which is negative 2. Divided by G at 1, which is 3, squared. All right, now from here we're going to simplify. Negative 2 times 3 is negative 6. And then negative 4 times negative 2 is positive 8. 3 squared is 9. Then negative 6 plus 8 is 2 over 9, which is 2/9. And that is my answer for part 4. All right, the last one is part 5, and it's saying you're going to look for h. You're given that h of x is equal to the composite function of f of g of x. And here you see a function within a function. When you see this, you know that you're going to be using the chain rule. The chain rule says that the derivative is equal to the derivative of f with respect to g of x times the derivative of g of x. All right, so here we find the derivative of h at 1. So we're going to go in, and everywhere we see an x, we're going to substitute a 1, just like we've done previously. So the derivative of h at 1, the derivative of f with respect to g at 1 times the derivative of g at 1. All right, so we're going to do some substitution. The last thing we're going to do is f prime. So first we're going to look for g at 1 on our chart. So g at 1 is 3. So we're going to substitute a 3 here. The derivative at 1, or the derivative of g at 1, is equal to negative 2. All right, so we're halfway done. Now we have to find the derivative of f at 3, which is 1/2, according to our chart. So 1/2 times negative 2. And I'm just going to write it as negative 2 over 1 because it's a whole number. You can write it as a fraction by placing it over 1. And that's negative 2 over 2, which is equal to 1. So the derivative of h at 1 is equal to, I'm sorry, not just 1, negative 1. All right, and that would be your answer to this one. And we are done. Hopefully this is helpful as well.